there are two different theorems for the net change. The one that we see most of the time is the second theorem, which says when I'm integrating and I have a lower limit of integration and I have an upper limit of integration, then what I do is I find the antiderivative and then I evaluate it at the upper limit first. So notice how I do the upper limit first, and then I do subtract the lower limit. So if I have the limits of integration, then I go ahead and evaluate it at those upper and lower limits, taking the antiderivatives. So I've done the derivative, so I integrate, so I find the antiderivative. And then I evaluate it at those two numbers. If I don't have the upper and lower limits, like this example here, I don't have the upper and lower limits, then if I don't have the upper and lower limits, then what I have to do is I have to put in plus c. And because we know from last quarter that if I asked you to do the derivative d dx, let me put it in a different color. If I asked you to do d dx of x squared, that's going to give me 2x. If I asked you to do d dx of x squared plus 3, that's also going to give me 2x. So we have a family of functions that will satisfy that derivative by a difference of a constant. And so as a reminder, if I don't see an upper and lower limit, then I'm going to do the derivative. I don't do any evaluation, and I slap on the plus c. So here are 4 examples. Which one of these 4 would you like me to do? And which one of these 4 would you like to do? So go ahead and put in the chat which one you would like me to do, and then you all get to do the other ones. The indefinite integral. So okay, so I'm going to go ahead and do this A. So what I'm going to do to make my life easy is whenever I see, I'll do A. So whenever I see radical, is I'm going to rewrite the radicals in exponential form so that I know easily how to do the integration. So this is going to be equal to the integral of, and when I see x, the square root of x, this is the same thing as x raised to the 1/2. So this is going to be x raised to the 1/2. And then minus, and then if I have 1 over x raised, or x square root of x, that's just going to make that a minus. And so it's going to be x raised to the negative 1/2 dx. Now, when we do derivatives, what we do when we do a derivative, so let's do a refresher of the derivatives for powers. When we are doing the derivatives for a power, so d dx, like I did x squared, then what ends up happening is that power comes down out front, and I raise that x to the 2 minus 1. So when I am integrating, I'm going to reverse that. So what I do is I add a power of 1 here, so I'm going to add 1 there, and then I also have to divide by whatever that exponent is once I added the 1. So I'm going to add 1 to each one of these, and then I'm going to divide by that number when I do the integration. So this is going to be equal to, when I add 1 to 1/2, that is 3 over 2. So this is going to be x raised to the 3 over 2. That means I have to divide by that 3 over 2. So I'm undoing the multiplication of the power, and I am undoing the subtraction of the power. So I have to add a power, and I have to divide by that power that I added 1 to. And then my other one is going to be minus. If I add 1 to negative 1/2, I get x raised to the 1/2. And then I need to divide by that power, which is 1/2. I'm going to put plus c. I'm just going to clean this up, and I'm going to use this rule that if I have, just like we've been doing, if I have 1 over a over b, then this is going to be b over a. So this is going to be equal to 2 over 3 x raised to the 3 over 2 minus 2 x raised to the 1/2 plus c, and that's my final answer. So on the homework for 1.4, do make sure that you, if it's a indefinite integral that you do a plus c, and it does have to be a capital C. So if you put a plus c and it's a lowercase, WebWork will say, I don't like you. And you want WebWork to like you because you want to be able to do the homework in a timely manner. So make sure that when you do this plus c, which mine actually kind of looks like an E, when you do this plus c, that make sure you do a capital plus c when you do the indefinite integration. All right, how was that? And stop a moment. And, okay, so I see a couple of questions. Where did the 3/2 come from and where did the 1/2 come from? So what I'm doing is when I'm doing the derivatives, I take my power, I subtract 1 from it, and then the power comes down. So when I reverse that to go from 2x raised to the 1 to go back to, so I'm integrating it, dx, I have to reverse that subtraction. So I do need to add 1 to it. And then whatever that power is, I need to divide by it. So 1 plus 1, I need to divide it back out. So that's how come I get the 2x. And then I don't know what the constant is, so I put plus c. So when I'm going from the integration, I am undoing that subtraction. So I'm adding 1 to it. So this was 1/2 plus 1, which is the same thing as 1.5. But I'm not going to write that as an exponent as 1.5, so I'm going to write it as in the equivalent improper fraction, which is going to be 2 times 1 plus 1, which is 3/2. So the 3/2 came from the fact that I had to add 1 to the 1/2 to go back to what it was before I did the derivative. And the great thing about the once you integrate is that you can always do the derivative now to see if I end up with what I started out with. So let's go ahead and do the derivative of 2/3 x to the 3/2 and then minus 2 x raised to the 1/2 to see if we end up with what we started out with, which is this. So if I'm asked to do the derivative dx, and this is the great thing about integration, so we can always check by doing the derivative to see if we got the same thing we started out with. So it's a really nice check. Plus c. So doing the derivative using the power rule for derivatives, my first one is going to be 2/3 multiplied by the power, which is 3/2 x. And I'm going to drop it down by 1, so 3/2 minus 1. So that gives me 1/2. And then minus 2 multiplied by the power, and then x raised to the negative 1/2. And then plus 0. So I did start out with, as you can see, these will cancel themselves out, and so you get x to the 1/2. Those cancel, minus x raised to the negative 1/2, and then plus 0. So I do have the correct function before I integrated, or when I do the derivative. So I think that may answer the question where the fractions came from. Maybe. All right, so I'm going to go ahead and put this on pause, and then I want you all to, if you don't have any other questions, go ahead and I'm going to put my recording on pause so you all have the opportunity to do these derivatives, or these integrals. So go ahead and work on these integrals, and then if you get stuck on any of them, just reach out to me, or you can just unmute yourself and say, hey, I'm getting stuck on one of these. This is the time in which I really, really, really miss being in the classroom, because I would go around and sit next to you and see how you're doing if you were confused. So please ask the questions. Don't just get stuck and sit there waiting for the answers. Ask the questions right out of the gate. Ask the questions. So I'm going to go ahead and put this on pause. So when you integrate sine, it's negative cosine. Is that what you said, negative cosine? And then this is where you check. The derivative of cosine is negative sine. And because this is positive right here, we have to adjust for that by being a negative right there. Is that what you said, is the negative cosine?
I said positive.
Okay, well,
I screwed up on.
That's okay. That's in the classroom is where you make the mistakes, and this is where I want you all to make mistakes. I don't want you to make the mistakes on the quizzes or the test. Make the mistakes on the homework. Make the mistakes in class. There's no judgment. This is where I need you to make the mistake so we can make the corrections here versus anywhere else. And then the cosine, to get cosine, what did you have to start out with to get cosine? Yeah, so sine.
Sine.
Yep, and so it's going to be just negative sine, and we don't have to worry about changing the sign on that because the derivative of cosine is, or the derivative of sine is cosine. Now, when we go to the evaluation, we're going from 0 to pi. So how do I move on from there? Anyone willing to unmute?
Do you do the f of the upper range minus f of the lower range, or the
Yep.
vice versa?
Yep, and so I'm going to do the evaluation of negative sine or negative cosine minus sine of pi. So I'm going to have negative cosine of pi and then minus the sine of pi. And this portion represents the f of your upper bound, which is b. Because when we integrate from a to b. So we found the antiderivative f, and we're evaluating on the upper limit. And then what else do I do?
F of upper limit minus f of lower limit. Right?
Okay, so now I'm going to evaluate it with a lower limit, so negative cosine of 0 minus the sine of 0. And this is f of a. So I will post, because I forgot to, I will post the formula sheet that I give to my Pre-Calc 2 students, which has the unit circle on it. So as you're doing your homework and as you're doing the quizzes and the tests, you want to have 3 things in front of you. You want to have your table of integrals, you want to have your table of derivatives, and you want to have the formula sheet that I give to my trig students so that you can find this stuff without doing any searching for them. So the cosine of pi happens to be -1. So this part equals -1. The sine of pi is 0, so this part equals 0. The cosine of 0 is equal to 1, and the sine of 0 is equal to 0. So what I have is I have the -1 minus 0 minus a -1 minus 0. So I end up with +1 and then minus a minus, so +1. So my final answer is 2. How was that?
And is that just because you distributed the negative between the two bounds?
Yeah. So to get the double negatives, these two, because the cosine of pi is a -1, so it's a negative cosine of pi, so it's a negative, that becomes positive. And then this negative has to distribute, and that's why that becomes a positive as well. How is that?
Pretty all right.
Pretty all right. Okay, so I'm going to have you work on D, and then we're going to come back to C, because it's U substitution. Now, we finished with U substitution the end of the quarter, but not all of you have seen it possibly, so, and we're going to be picking up U substitution when I see you all on Monday. So go ahead and do D. Now, D's are pretty straightforward. In fact, these are all just powers. So you're going to add a power, divide by whatever that power is after you've added one, and then evaluate from -1 to 1. So I'm going to put this on pause for a minute and give you all the opportunity to do D, and then I'm going to do C.